New opportunities often begin with small machines that quietly reshape how products are made. In 2026, compact manufacturing tools are becoming more efficient, more accessible, and more capable of turning raw materials into finished items with surprising speed. Today, we're taking a closer look at 10 machines. Each one shows how much can be produced from a small workspace when the right technology is involved. Carpet Edging Machine. A carpet edging machine reinforces and finishes the borders of carpets, rugs, and mats using strong stitching or binding techniques. The process begins by placing the carpet's raw edge under a guided presser foot. The machine feeds the edge through a specialized needle and looper system that wraps durable thread around the border. This prevents fraying, strengthens the material, and gives the carpet a polished appearance. Tabletop versions are designed to handle various carpet thicknesses using adjustable tension, stitch width selection, and sidewalking feet to maintain alignment. Operators can choose from cotton, nylon, or polyester threads depending on the desired edge finish. The machine's motor drives the needle at a steady pace, allowing the operator to guide curves, corners, and straight edges smoothly. As the carpet passes through, the stitching forms a reinforced band that protects against long-term wear. This type of machine is commonly seen in upholstery rooms, carpet shops, and small repair studios. It demonstrates how a simple edge treatment can significantly improve durability and overall presentation, turning raw materials into finished products ready for daily use. Puffed Rice Cake Machine. A puffed rice cake machine uses heat and pressure to transform compacted rice grains into light, airy cakes. The machine begins by loading a measured portion of rice into a heated mold chamber. As the chamber closes, internal pressure builds rapidly. When the pressure releases, the rice expands instantly, filling the mold shape and forming a crisp, circular cake. This quick expansion process is what gives rice cakes their distinct texture. Compact models use electric heaters, temperature regulators, and automated mold cycles that allow users to observe the transformation closely. Each cycle produces a consistent shape, with the thickness and diameter controlled by the mold plate. The rhythmic popping sound during operation makes the process easily recognizable. Once released from the mold, the cake cools and maintains its structure. By adjusting the input grains, molds, and heating levels, different textures and styles of rice cakes can be produced. Machines like this highlight how simple grains can be reshaped using heat and controlled pressure, offering a clear view of food-forming processes used in snack manufacturing. Coconut Grinding Machine. A coconut grinding machine shreds fresh coconut meat into fine or medium strands using rotating blades. Operators begin by placing halved or peeled coconut meat into the machine's feeding inlet. Inside, a drum lined with sharp serrated teeth grinds the coconut as it spins. The grated output falls through a chute into a container, ready for further processing in cooking, oil extraction, or sweet production. Compact models typically include stainless steel drums, splash guards, adjustable blade settings, and easy-to-wash components. The motor drives the drum at high speed, ensuring consistent shredding regardless of coconut size or firmness. Observing the grinding process reveals how mechanical abrasion can quickly break down fibrous foods into uniform textures. This machine replaces the slow manual scraping traditionally done by hand, offering a steady method that keeps the texture consistent. It also illustrates how rotating blades and simple feeding systems work together to process dense food materials effectively. Lipstick Filling Machine. A lipstick filling machine dispenses melted cosmetic mixtures into empty lipstick molds with precision. The machine includes a heated tank to melt the wax-based formula, a temperature control system to prevent overheating, and a filling nozzle that releases measured amounts into the molds. Once the melted mixture reaches the correct viscosity, it flows through insulated tubing toward the mold cavities. Small tabletop versions allow users to adjust filling speed, nozzle size, and temperature to ensure smooth flow. After filling, the molds are cooled to solidify the lipstick, and the finished sticks are removed for casing. The process shows how cosmetic components like waxes, oils, pigments, and fragrances combine into a uniform product using heat and controlled pouring. Watching the machine work highlights the importance of consistent temperature, especially since minor changes affect texture and smoothness. These compact systems replicate the same steps used in full-scale cosmetic facilities, but in a format suitable for small batch production and experimentation. Nail-making machine. A nail-making machine cuts, shapes, and points steel wire into finished nails through a sequence of mechanical operations. The process begins with a coil of steel wire fed into the machine. A gripper mechanism pulls the wire to a set length, where a cutting blade chops it to size. One end is shaped into a head by striking it with a forming punch, while the other end is tapered into a sharp point by angled cutters. Once formed, the nail drops into a collecting tray. Compact nail machines include lubrication systems, automatic wire feeding, adjustable length controls, and hardened steel dies to ensure precise shaping. Each cycle produces a nail within seconds. Observing the synchronized movement of punches, cutters, and feeders offers a detailed look at metal forming. The machine demonstrates how repetitive processes, cutting, compressing, shaping, and trimming, can transform simple wire into uniform hardware used in construction, carpentry, and manufacturing. Garlic peeling machine. A garlic peeling machine separates garlic cloves from their thin outer skins using controlled airflow or abrasion. The cloves are loaded into a chamber where a gentle air pressure lifts and removes the dry skins, leaving the cloves smooth and intact. Some versions use rotating drums lined with soft rubbing surfaces to loosen skins without damaging the cloves. Airflow-based systems rely on a blower and cyclone separator that pull away the loose skins through a duct. Compact machines include moisture regulators to keep garlic at the right hydration level for peeling efficiency. The process reveals how airflow, pressure balance, and surface friction work together to remove delicate outer layers without breaking the cloves. It eliminates the slow process of hand peeling, offering clean, ready-to-cook garlic for kitchens or food processing setups. The machine's design demonstrates how precise force application can handle fragile ingredients effectively. Cupcake tray making machine. A cupcake tray making machine forms paper trays or baking cups from laminated sheets using heat and pressure. The operator places a stack of paper sheets into the feeding station. The machine then uses heated molds to press the paper into shaped cavities, creating uniform cupcake holders. A cutting mechanism trims excess material around the edges, leaving a clean, fluted cup. Compact models often include automatic paper feeding, mold heating controls, and adjustable forming speeds. Watching the forming molds press into the paper shows how shape retention happens when heat softens the laminated layers, just enough to bend without tearing. The machine provides a clear demonstration of forming techniques used in packaging and baking industries. By adjusting mold sizes, operators can create cups for mini, standard, or large cupcakes. The process shows how flat materials turn into functional containers using compression and thermal shaping. Wire mesh fence machine. A wire mesh fence machine weaves or interlocks galvanized wires into the familiar diamond-patterned chain link fencing. The process begins with straightened wire fed through forming wheels that bend it into zigzag shapes. As each new segment forms, it interlocks with the previous one, creating a continuous woven structure. Cutting tools trim the ends, while twisting mechanisms wrap the top and bottom edges for reinforcement. Compact models allow users to adjust mesh size, wire thickness, and height output. The synchronized movement of forming wheels demonstrates how simple bending techniques generate strong fencing patterns. These woven structures require precise alignment to maintain uniform openings. The machine shows how metal flexibility, controlled tension, and repetitive interlocking motions create a stable and widely used fencing material. Observing the weaving process makes it clear how everyday fencing is built from basic metallic strands. Laser cleaning machine. A laser cleaning machine removes rust, paint, oxidation, or surface contamination using high-energy laser pulses. When the laser beam hits the surface, it vaporizes the unwanted layer without damaging the base material beneath. Portable versions use fiber laser technology coupled with handheld scanning heads. Operators control intensity and scan speed using onboard settings or a touch panel. The process produces minimal waste since removed material evaporates or becomes fine dust collected by optional filtration systems. Observing the laser pass across metal surfaces shows how precisely the beam interacts with contaminants. It reveals how focused light energy can replace traditional abrasive or chemical cleaning methods. The handheld design allows users to move across large surfaces or detailed areas with ease. The machine highlights how controlled laser pulses deliver selective cleaning while maintaining the structural integrity of the underlying material. Cable granulator machine. A cable granulator machine separates valuable copper from plastic insulation found in discarded cables. The machine starts by pulling cables through a cutting chamber where rotating blades chop them into small pieces. These pieces then pass through a granulation unit that further reduces them into fine particles. A separation system, often involving airflow or vibration, divides heavy copper particles from lighter plastic fragments. Clean copper exits from one chute, and the separated plastic exits from another. Compact granulators include dust collectors, replaceable blades, and adjustable airflow settings for efficient separation. Watching this machine in action provides a detailed look at material density differences and how mechanical processes exploit those differences to separate components. Cable granulators show how recycling operations break materials down into reusable forms through cutting, granulating, and sorting. Pipe bending machine. A pipe bending machine shapes metal pipes or tubes into curved forms using a combination of dies, pressure rollers, and bending arms. The operator places a pipe into the bending die, clamps it in place, and sets the desired angle. As the machine activates, the bending arm or hydraulic ram applies smooth, steady pressure, causing the pipe to conform to the die's curvature. Compact versions include manual, hydraulic, and electric models suitable for small workshops. They allow precise control over bend radius, angle, and pipe placement. The machine demonstrates how controlled force and mechanical leverage transform rigid tubes into functional shapes used in furniture, automotive components, construction frameworks, and equipment assembly. The smooth motion of the bending process shows how metal can be shaped effectively without compromising structural integrity when proper support and alignment are used.